All right, everyone, get ready, because today we're going deep into quantum computing and cybersecurity. I know what you're thinking. It sounds a little bit like a sci-fi movie, right? Like supercomputers cracking all our codes and stuff. But no need to panic. We're here to break it all down. You guys sent in a bunch of articles on this topic, and we did a deep dive into all of them so you don't have to. We'll keep it simple, no jargon, just the stuff you need to know.
Exactly. And I think the first thing to understand is that quantum computing is like a whole new world. It's completely different. Imagine a computer that can be like a 0 and a 1 at the same time. So it can do tons of calculations at the same time. It's pretty wild. It has the potential to like revolutionize a lot of things, but it also brings up some big questions about cybersecurity.
Okay, so let's talk about those challenges. The big question on everyone's mind is, are our current security systems going to just become useless because of these supercomputers?
Well, it's not really about things becoming useless. It's more about adapting and evolving. The good news is that the cybersecurity folks are already on it. They know about this potential threat from quantum computers, and they're working on solutions.
That's good to hear. But before we get into the solutions, let's talk about what's at stake here.
Ah.
A lot of the articles you sent in mention something called public key cryptography. What is that exactly, and why is it vulnerable to these quantum attacks?
Public key cryptography is basically how we keep everything secure online.
Okay, so like our online banking and stuff.
Exactly. It's how we send information securely over the internet, how we do online transactions, how we verify digital identities. You can think of it like a digital lock and key system, but with a little twist.
A twist. Okay, now I'm interested. Tell me more.
Okay, so imagine you have a mailbox with two keys. One key locks it and the other unlocks it. The lock and key is public. Anyone can use it to put mail in your box. But the unlocking key is private. Only you have it. So that's kind of how public key cryptography works. You have a public key that anyone can use to encrypt information, but only the person with the private key can decrypt it.
Oh, I get it. That's a really good analogy.
Yeah.
So how do quantum computers mess this up?
So there's this quantum algorithm. It's called Shor's algorithm, and it can like quickly figure out the factors of really big numbers, which is how a lot of public key crypto systems work. So basically, a strong enough quantum computer using Shor's algorithm could crack the codes that protect, a lot of our data today.
Oh, wow. So like someone could steal encrypted data now and then just wait until they have a quantum computer and decrypt it then.
Yeah, that's a real concern. It's what they call the harvest now, decrypt later scenario.
Okay, that is a little unsettling.
It is. But remember, cybersecurity people are on top of this. They're working on things that can even hold up against the strongest quantum attacks.
Okay, good. That brings us to the good news then, right? What about those solutions? The articles mention something called quantum-resistant cryptography. What is that, and how does it work?
So quantum-resistant cryptography is all about coming up with new types of encryption, stuff that's designed to be safe even against attacks from quantum computers. Basically, we're trying to find math problems that are super hard for both normal computers and quantum computers to solve.
So we're trying to outsmart the hackers of the future. We're making codes they can't crack.
Yeah, pretty much. And there are some really cool ideas being developed.
Like what?
Well, one of the most exciting is called lattice-based cryptography.
Lattice-based cryptography. That sounds kind of sci-fi.
I know, right? But it's actually a pretty simple idea. Imagine like a big multidimensional grid, like a giant jungle gym with points all over it. The challenge is to find the shortest path through the grid. And that gets really, really hard as you add more dimensions and more points.
So even with all their power, quantum computers would still have trouble finding the shortest path.
Exactly. And that makes lattice-based cryptography a really strong contender for the future. It's already being used in some places.
That's great. So we have lattice-based cryptography. What else is out there?
Well, there's another cool one called homomorphic encryption. It basically lets you do calculations on encrypted data without ever actually decrypting it.
Wait, what? How is that even possible?
It's pretty amazing. It uses some fancy math to let you work with the encrypted data without ever seeing the actual information.
Wow.
Yeah, it's like something out of a spy movie. And it's still pretty early. But homomorphic encryption could be a game changer for data privacy and security. Like, imagine a world where we can share sensitive information without ever worrying about it getting into the wrong hands.
That would be amazing.
It would. And there's more. It's not just lattice-based cryptography and homomorphic encryption that are giving us hope. There's also quantum key distribution, or QKD for short. It uses quantum mechanics to create super secure communication channels.
Okay, now you're really talking my language. Quantum mechanics. This, I gotta hear.
So imagine you want to send a secret message to a friend, and you need a secret key to encrypt and decrypt the message. With QKD, you can use particles of light, photons, to transmit the key. And the cool thing is that if anyone tries to mess with these photons, they'll change their quantum state. You'll know someone's trying to eavesdrop.
So it's like a built-in alarm system. If someone tries to listen in, you'll know.
Exactly. Any attempt to spy on the communication will be detected. It's almost impossible to steal the key without getting caught.
That's amazing. So we're using quantum mechanics to our advantage. We're creating unbreakable communication.
That's the beauty of it. And QKD is not just some theory. It's already being used in the real world, especially for governments and financial institutions to secure sensitive communications.
Wow, that's impressive. So we have lattice-based cryptography, homomorphic encryption, and QKD. It sounds like we have a lot of tools to fight back against these quantum hackers.
We do. And the best part is that research and development is happening all the time. There are new and even better solutions coming out all the time. The cybersecurity folks are always pushing the limits to make sure we're safe in a quantum world.
This is all so encouraging. I have to admit, when I first started reading about all this, I was a little worried. But now, I'm feeling much more optimistic.
That's great. We have the people, the resources, and the drive to stay ahead of the game.
Okay, so we've talked about the threats and the solutions. But let's get practical for a second. What does all this mean for the average person? What can we do to protect ourselves in this quantum world?
That's a good question. And the answer is actually pretty simple. The same good cybersecurity habits we have now will still be important in a quantum world.
So things like strong passwords, being careful about links, keeping our software up to date.
Exactly. Those are all essential no matter what kind of computer is trying to attack us.
So it's not about learning a whole new set of rules. It's about sticking to what we already know.
Right. And as quantum-resistant technologies become more common, we can start using those too.
That makes sense. So it's about staying informed and adapting. But let's be real. Moving to a quantum-secure world is a huge task. What are some of the challenges we need to be aware of?
Of course, there are always challenges, especially when we're talking about something this big. One of the biggest is standardization. We need to make sure everyone's on the same page and that the quantum-resistant solutions we create can all work together.
Right. If everyone's using different systems that can't talk to each other, that's going to be a mess.
Exactly. So collaboration is key. We need governments, industry leaders, researchers, all working together to set clear standards for how we do this.
So it's a team effort.
Absolutely. And another challenge is cost. Moving to quantum-resistant technologies is going to take a lot of investment in research, development, and infrastructure.
So we need to make these technologies available to everyone.
Exactly. Not just big companies and governments. Small businesses, individuals, developing countries. Everyone deserves to be safe online.
I agree. So standardization and costs are two big ones. Anything else we should be thinking about?
Well, education and awareness are really important too. We need to make sure people understand the risks and the solutions.
So empowering people with knowledge so they can protect themselves.
Yes. And that includes policymakers, business leaders, the general public. The more people understand, the better we can deal with this together.
It sounds like we have a lot of work to do. But it also sounds like an exciting time to be in cybersecurity.
It is. The quantum era is full of challenges and opportunities. If we embrace the possibilities and deal with the risks head on, we can create a future where technology works for us without compromising our security or privacy.
That's a great point.
I think that's a good place to stop for now. We've covered a lot of ground today, from the potential threats of quantum computing to the exciting solutions being developed. When we come back, we'll dive into a specific example of how quantum-resistant technology is already being used to protect sensitive information.
That sounds great. Stay tuned. Welcome back to the Deep Dive. Before the break, we were talking about all the cool stuff researchers are doing to stay ahead of the quantum computing game. It's kind of like a race, right? But at least we have some really bright minds on our side.
Yeah, definitely. And it's not all just theory. A lot of these quantum-resistant technologies are already out there in the real world.
Really? That's awesome. Can you give us an example of how that's working?
Sure. Let's take the financial sector, for instance. Banks and those kinds of places, they deal with a ton of sensitive data. And they were some of the first to realize the potential threat from quantum computers. So they've been pretty proactive about looking into quantum-resistant solutions.
Yeah, that makes sense. I mean, when you're dealing with people's money, security is everything.
Exactly. And one area where they're making a lot of progress is in securing financial transactions, like all those electronic payments we make every day. Online shopping, transferring money between accounts. All of that relies on encryption to keep our financial info safe.
So how are they using these quantum-resistant technologies to protect those transactions?
Well, some banks are already trying out these quantum-resistant algorithms to encrypt their data. These algorithms are designed to be resistant to attacks from both regular and quantum computers. It's like an extra layer of protection.
So even if someone stole the data today, they couldn't decrypt it later, even with a quantum computer.
That's the idea. By implementing these solutions now, banks are really taking steps to protect their customers in the long run.
That's good to know. It's reassuring to know they're taking this seriously.
Yeah, they are. And it's not just banks either. Governments and other organizations are also getting on board with this. It's a global effort, which is encouraging.
It sounds like we're moving in the right direction. But this is a really complex field, and it's changing all the time. What can our listeners do to stay informed about all this?
There are a lot of great resources online. Organizations like NIST and ENISA are doing a lot of research on this, and they publish regular updates and guidance on what to do.
So we just need to stay curious and do a little research. We'll make sure to include links to those resources in the show notes for everyone.
Perfect. Remember, knowledge is power. The more we all understand about quantum computing and cybersecurity, the better prepared we'll be.
Well said. This deep dive into the quantum world has been a wild ride. I was a bit nervous at first, but honestly, after hearing all this, I'm feeling much more optimistic about the future.
That's great to hear. That's what we were hoping for. The main thing to remember is that quantum computing presents challenges, sure, but it also brings new opportunities. If we work together and stay innovative, we can create a safe and successful future for everyone.
I agree. This has been a fascinating conversation. Thanks for sharing your expertise with us.
It's been my pleasure.
And to our listeners, thanks for joining us on this deep dive into the quantum realm. We hope you found it informative and maybe even a little inspiring.
Definitely. Remember, the future of cybersecurity is up to all of us. Stay curious, stay informed, and stay safe.
And if you enjoyed this episode, don't forget to subscribe and share it with your friends. We'll be back soon with another deep dive into another fascinating topic. Until then, stay curious. Welcome back to the Deep Dive. Before the break, we were talking about how researchers and cybersecurity experts are working hard to stay ahead of the game when it comes to quantum computing. It's like a race against time, but the good news is that we have some seriously smart people on our side.
Absolutely. And it's not just about theoretical solutions. Many of these quantum-resistant technologies are already being put to use in the real world.
Oh, really? Okay, now you've got my attention. Could you give us an example of how this is actually playing out?
Sure. Let's talk about the financial sector. As you can imagine, banks and financial institutions handle incredibly sensitive data. They were among the first to recognize the potential threat posed by quantum computers, and they've been proactive in exploring quantum-resistant solutions.
Yeah, that makes sense. When you're dealing with people's money, security is paramount.
Exactly. And one area where we're seeing real progress is in securing financial transactions. Think about all the electronic payments we make every day, from online shopping to transferring money between accounts. All of these transactions rely on encryption to protect our financial information.
Right. So how are quantum-resistant technologies being used to safeguard these transactions?
Well, some banks are already experimenting with quantum-resistant algorithms to encrypt sensitive data. These algorithms are designed to be resistant to attacks from both classical and quantum computers, providing an extra layer of protection for our financial information.
So even if someone were to steal this encrypted data today, they wouldn't be able to decrypt it even with a powerful quantum computer in the future.
That's the goal. And by implementing these solutions now, banks are taking proactive steps to protect their customers and ensure the long-term security of their systems.
That's really reassuring to hear.
Yeah.
It's good to know that the financial industry is taking this threat seriously and taking action to protect our money.
They are, and it's not just banks. Governments and other organizations are also exploring quantum-resistant solutions to protect their sensitive data. This is a global effort, and the progress we're seeing is incredibly encouraging.
It's great. It sounds like we're on the right track. But this is a complex and constantly evolving field. What can our listeners do to stay informed and up to date on the latest developments?
There are some great resources available online. Organizations like the National Institute of Standards and Technology, NIST, and the European Union Agency for Cybersecurity, ENISA, are actively involved in quantum-resistant cryptography research, and they provide regular updates and guidance on best practices.
So it's about staying curious and doing a little research. We'll be sure to include links to some of these resources in the show notes for our listeners.
That's a great idea. And remember, knowledge is power. The more we understand about quantum computing and its implications for cybersecurity, the better equipped we'll be to make informed decisions and protect ourselves.
Well said. I have to say, this deep dive into the world of quantum computing and cybersecurity has been an incredible journey. We started off with a bit of apprehension, but thanks to your insights, I'm feeling much more optimistic about the future.
That's what we were hoping for. The message we want to convey is that while quantum computing does present challenges, it also presents opportunities. By working together and embracing innovation, we can create a secure and prosperous future for everyone.
It's been a fascinating and eye-opening conversation. Thank you so much for sharing your expertise with us. And to our listeners, thanks for joining us on this deep dive into the quantum realm. We hope you found it informative and empowering.
It's been a pleasure. Remember, the future of cybersecurity is in our hands. Stay curious, stay informed, and stay safe.
And if you enjoyed this episode, be sure to subscribe and share it with your friends. We'll be back soon with another deep dive into a fascinating topic. Until then, stay curious.